Hey everyone, welcome back to The Explainer. Today, we're diving into something that is, honestly, kind of mind-blowing. Have you ever actually stopped to think about how a messy, abstract human thought, or even just a simple line of code floating way up in the cloud, somehow translates directly into a physical, real-world action? Well, today we're going to track a single thread of logic from the completely abstract digital realm all the way down to a literal physical robot sitting right on a desk.
Because think about it, how does a line of code actually safely move physical reality? We have to ask this foundational question because there's this massive, gaping chasm between our intent in the cloud and the actual physical machines we're trying to control. You know, we intuitively feel like computers just kind of get us, right? You click a button, something happens. But bridging that gap without the whole sequence just totally crashing, that is an incredible mystery and a monumental engineering challenge.
So, here's our roadmap for the day. First, the digital-physical divide. Second, ERC7827 and the root. Third, LIFO single-entry bookkeeping. Fourth, crossing the semiotic bridge. And finally, Cheerbot and GPIO execution. Let's just jump right in.
All right, starting off with part one, the digital-physical divide and the chaos of event-driven programming. So how does an abstract piece of code actually move a motor? Historically, trying to map ledgers to machines has been an absolute mess. Look at the falling dominoes on the left there. Traditional event-driven programming is exactly like that. It's totally chaotic. You get a single delayed signal, maybe an event fires twice, or some hardware state just falls slightly out of sync, and bam, the entire sequence is ruined. To actually cross this divide safely and reliably, we desperately needed the root-to-leaf architecture you're seeing on the right. It's a system that demands strict, bit-perfect, deterministic execution, no exceptions. Moving right along to part two, ERC787 and the root, or how we actually anchor the digital state. Okay, so to build a flawless bridge, developers had to completely scrap that old metaphor of a floating data tree. Because, well, you can't just float off into the digital ether if you're trying to perfectly control physical reality, right? You absolutely must be anchored. And that anchor is the ERC7827 protocol. It introduces this concept of value version control, which basically takes your standard lightweight JSON and transforms it into an incredibly rigorous, bit-perfect, mathematical smart contract layer. It acts as the crucial protocol trunk, or root, locking down that bit-perfect version control while still being completely backwards compatible with the web protocols we're all already using. Which brings us to part three, LIFO single-entry bookkeeping and achieving total determinism at index 0. So, to maintain that bit-perfect version control, the underlying architecture relies on a very specific mathematical engine, the LIFO ledger. That stands for last in, first out. By totally pivoting away from the usual chaotic first-in, first-out structures, you unlock this insanely efficient single-entry bookkeeping. Because it queries only index 0, you get an immediate mathematical proof of state without having to drag through some massive history of transactions. It guarantees your systems can verify data with absolute certainty and speed. To make this super easy to visualize, think of this engine like a really, really efficient bouncer at a busy club. This bouncer does not care about the whole line. They only need to look at the ID of the person standing directly in front of them, right at index 0, to instantly know the absolute state of the line. It strictly checks that single most recent entry. There is zero ambiguity here. The state is either mathematically true or it isn't. No in-betweens. We have officially locked down absolute digital truth. All right, part 4, crossing the semiotic bridge using what's known as the surgical trunk. I absolutely love this quote because it perfectly captures the philosophy behind how we cross this bridge. You wouldn't build $1 million hyper-complex robotic arm just to pick up a single piece of sushi. You just use 2 simple sticks, right? This is exactly what developers call chopsticks design. For years, engineers hit this massive brick wall of complexity, trying to use bloated Ricardian smart contracts to move physical things. Chopsticks design throws all that out in favor of surgical, lightweight webhooks. And here's how that builds into an ingeniously simple client callback loop. Step 1. Instead of panicking with a giant, heavy contract, the server literally just triggers a dormant 30-year-old internet status code HTTP 402, payment required. Step 2. The client's wallet jumps in and signs a cryptographic proof. Step 3. The client simply retries the exact same HTTP request, flashes the receipt, and the server instantly unlocks the resource. It's a totally deterministic, event-driven loop. Boom, done. And finally, Part 5, Cheerbot and GPIO Execution, the ultimate physical payoff. This is it, the climax of our explainer. We are at the absolute bottom of the funnel, the very edge of the digital universe where pure math actually becomes tangible movement. Meet the Flow X42 Cheerbot. Tucked inside this little shell is a localized Raspberry Pi microhost, and it's just sitting there, calmly reading that on-chain LIFO tree we just covered, waiting for a verified state change. It's incredible. It proves that a digital protocol trunk can actually safely bypass centralized intermediaries entirely. Let's walk through this final sequence of leaf node logistics. When a verified digital tip hits that surgical webhook, the cryptographic proof is signed and validated using that single entry bookkeeping right at LIFO index 0. And then the magic happens. The Cheerbot reads that bit-perfect JSON state and literally translates it into raw electrical signals fired straight into the tiny GPIO pins, the general-purpose input-output pins, on the Raspberry Pi. The verified code literally shocks the physical leaf node into action, spinning a motor or turning on a light. Pure math literally becomes electricity. It's wild. There's this profoundly deep quote from the architecture documentation that I think frames exactly what we've achieved here today. The human pilot applies the intent, but the agent cell executes the sweat, bridging that massive gap between messy human desire and strict deterministic machine execution. By marrying the structural mathematical order of an ERC 7827 ledger to the physical nervous system of hardware pins, we've basically smashed right through decades-old technical walls. So we've traced this incredible journey together today, from an anchored digital route down through a perfectly verified LIFO ledger, across that surgical chopsticks callback loop, all the way to a little physical robot waking up on a desk. The semiotic bridge from digital truth to physical reality, it is officially wide open. So I want to leave you with one final question to chew on today. Now that this bridge is built and wide open, what are you going to program physical reality to do? Thanks so much for hanging out with me for this explainer. Keep learning, keep exploring, and I'll catch you next time.